Okay, just a quick recap. No one? Okay. Everybody's sleepy, I think. Okay, so in reinforcement learning, what do? We have set of states, set of actions, possible actions that can be taken on states, and then we move from agent takes some action, move to a new state, and it gets some reward. So this is the whole functioning of a reinforcement learning. Now, simple example. So what do we do in reinforcement learning? It learns by previous experiences, while in general, in supervised learning, it learns by set of examples, that is inputs, outputs, x and y that we have. So in reinforcement learning, it learns by experience. Okay. So example, can any one of you give me example of reinforcement learning?
Self-driving car, ma'am.
Games, self-driving cars, chess, so many other games. All are examples of reinforcement learning. So I'm giving you another example, which if you understand, you will get more clear about this. Suppose I have a game. I want to reach to position this from any position that I'm having currently having in, and this, if I reach to this position I win, if I reach to this position I lose. Okay, so win and lose means I will get reward plus 1, and if I reach to this position B, I will get reward minus 1. All right, now I can not move into horizontal direction. I can move in this horizontal and vertical. I cannot move into diagonal direction. It would be horizontal or vertical. All right, so suppose I was at this location. Now, reward, basically reward decides my policy. Rewards and my present environment, basically plus environment, decides my policy. How? So, policy is basically strategy that I'm going to follow because I'm here at position, some position, and my goal is I want to reach to A. Okay. So policy is either I can move to this direction. I have three options right now. I can take three actions right now. So policy is strategy, that steps that are going to follow to reach to this A. Okay. Now suppose I get a reward of this whole system is stochastic system. Stochastic means even if I move, stochastic means 100%, there's no 100% probability for if I choose to go into this direction, it may or may not go into this direction. If I say that, okay, 80% chance, if 80, 10 and 10, so if I'm moving to this direction, there are 10% chance it will go left and 10% chance it will go right. Okay. So in a stochastic system, suppose I am moving from C, I was initial position C, and I want to go to A. Okay. So if I move from C to D in a stochastic system, there are chances that I might end up in B, right? then I'll lose. Okay, so I will, what path do I select? I will select this path, this one, right? Because I want to make 100% sure that I reach to A. Okay, so instead of going from C to D, then to A, I will choose this leftmost path, C to E, to F, to G, and then to A. Alright, so I will choose this path instead of C to D. Now, how do my reward changes my policy? So reward is basically, environment was stochastic. So we have discussed, okay, if it is stochastic, so there are chances it can move from, uh, it may not do what it was ought to do, because there are some chances that it will do something else, right? Now rewards, how do rewards decide that what is my policy? Suppose from taking one step, my reward was, let's say 0 point minus 0.04. Okay, so even if I go from C to E to F to G to A, if I go to this path, okay, so this path, so my total reward will be, suppose, just I'm not including discount factor here, so I'm just saying, from C to E it would be, uh, uh, minus 0.004. Then from E to F it would be plus minus k minus 0.04. Then F to G would be plus minus 0.04. And then from up till A it would be uh, minus 0.04 and minus 0.04. Then if I reached A, it would be plus 1, right? So if you add all this, it would be approximately 0.9 something, 0.8 or 0.8 and 0.9 is a pretty good value, right? So you say, okay, I C to E to F to G to A, this path is okay, so it suits me. My reward was 0.004. Now suppose I set my reward from 0.004 to, let's say I set it to minus minus 2.0. I have set my reward too high. This means even if I take one step, that one step is so costly that it can lead me to the, it's minus 1, or let's say minus 1.0. So one step is too costly, so I cannot afford to take this longest path. So which path I'll take? I will take C to D, even if there are chances I will land to B. I will land to minus 1 state. So right, what I'm so you are getting what I'm saying. So my policy is dependent upon the reward that I have, plus the environment right now that I have. Okay, if it was not a stochastic environment, it was a deterministic environment, which means that if I am moving from C to D, there are 100% chances it will land up in D only. ठीक है, so 100% chances that it will go from C to D only, it will not move either left or right. So if it's a deterministic system, in that case you will not take the longest path, you will definitely go with the C to D, then to this upper cell, and then to A, right? So this is overall idea. Okay, so this is how reinforcement learning works. Now, reinforcement learning is, up till now we have seen that we have been deriving knowledge, extracting knowledge, and this knowledge is in terms of learned in terms of parameters of a model, neural network model parameters we learn. And what do these parameter represents? These parameter represents the values, basically, which the whole system, it represents the whole system that right now you have seen. You have seen the training data already, and you have set of parameters, so these parameters represents your system. And now for new data, you classify it, you predict it, you perform so many operations. So that knowledge is in terms of parameters, model parameters that you have, right? While in deep learning, it is much more than this. It depends upon the action that you take, and it learns from the action that you take. So if you are moving from one state to other, it will learn this, and it will store some value, and it will in future it will see that from the value that from action that you have taken in future, it will see that how productive that action was, and whether in such a state, in such a situation, should I take such actions or not. Okay, so deep learning is much more than deep reinforcement learning is much more than simple deep learning where we just have knowledge, while in reinforcement learning we take actions and we decide based on the previous our past experiences that we want to take some we that this for me or not, this action will lead to my goal or not, this action will make me win or lose, right? So deep learning is much deep reinforcement learning is much more than deep learning. Now not we have discussed this somewhat in the last class also. We have basically value based and policy based in the last class. So there are three types of reinforcement learning, types of reinforcement learning problems, way that you can solve this problem. So first is model based. So in model based we learn the whole model, just as we do simply we say okay, a model is nothing, just a set of past experiences. So in a model we have played a game, let's say game 1, game 2, we have played 50 games. So model is learned based on all these 50 games. And now whenever a future in future we want to play, we will extract knowledge from this model which has already learned from 50 games, and then we will use this model to take actions in the future, right? So this is model based. While in value based there's advantage that instead of learning a model, instead of doing this is entirely different from this model based. We don't learn a model, it's just a greedy approach. So in greedy approach, what do? Is we see what is right for me right now, even if my right now action in longer term will affect me badly. So right now I will see that okay, I'm in state S naught, and A1 action, A2 action, and A3 actions are there. So I will select the action which one is the right now which seems best to me. Okay, so I will select action A1 and then I will move to S1. Again, I'll repeat this process. I will not follow a policy, I will not follow a strategy. Okay, I will just see whatever right now is best for me. I will check the state action pair value, and if it is highest, best, I will choose the optimal one right now. Okay, so in value based, we don't have a proper strategy that okay, suppose it was this model was suppose this was SN state, which is final state, and started from S naught, and we know that if I go to this set of states, it will always make me win. So it will always reach to a state where I win. So in value based, it do not follow the sequence of steps. Right now, what is best, it selects that one. Okay, in policy based, what it does is it selects the particular strategy. There are set of strategies and it says okay, it will learn set of strategies that okay, if I have followed these sequence of steps, I will reach to my final goal. So in policy based, they learn the policy and the whole sequence of steps. Okay, if I follow this, then this, I will definitely will win, right? So this is policy based. uh, so okay, so dqn is nothing, q value based or q value. So this is one and the same thing. So what we are going to discuss today is this one. Okay, value based. So q learning is nothing, we are just learning the present value of state action pair. We have discussed this somewhat also, we have discussed Bellman equation in last class. So that equation is used to learn the present best value of the system of this of that particular state. Okay, so DQN is a network, proposed by Google DeepMind, and this these networks were pretty popular, and these are based on value based. learning. Okay, we'll see how this works. So in Q learning, what happens is we have seen that every state we select out of these three best possible actions, which one is best for me. I will select this one, and again out of these, which one is best, I will select that one. So right now R is the reward. So reward is basically the sum of all the future rewards that I can get. So we have discussed this in last class also. So it plus 1 is reward at time t plus 1, and this gamma is a discount factor. So as we are moving from state S1 to S0 to S1 to S2, so this was time t0, time t1, time t2. So I will get some reward R1, I will get some reward R2, and so on. Okay, so if I add all those rewards, so for right now I will have a sum of all these rewards. So it will be gamma R1 plus generally it is gamma square R2 plus gamma 3 R4. So we keep on reducing discount factor as time goes on, because last state does not affect my present state that much, but S1 affects my present state S not very much. So that's why gamma over here. Generally, we use this strategy. Okay, and this process keeps on increasing as we go on. So this is the present, this is my present reward, which depends upon all the sum of all the future rewards, right? Okay, so over here, so state action value function or q value function is the expected return when starting in S, performing A and following a policy P. Okay, so this policy can change. Okay, so under a policy P, if I'm taking state to action, I'm moving from at state, I'm selecting action A. So q learning is any policy out of all the set of pies. You have pi 1, pi 2, you have so many strategies. Out of this, select any one to estimate q that maximizes the future reward. So my aim is to maximize this r out of, so this r was for policy pi 1. So pi 1 says if I go from S0 to S2, maybe pi 2 says that I go from S0 to S2 directly, then S5 and then S10. This will give me more better reward. Okay, so out of these policy pi 1 and pi 2, which one should I select? So any policy to estimate Q that maximizes the future reward, Q directly approximate Q star, which is Bellman equation, and independent of the policy being followed. So it does not depend upon should I follow pi 1 or pi 2. I can select anyone depending upon the present state I am in. Okay, and only requirement is to I have to keep updating each state action pair. I just keep updating it. Okay, and how do we update this one? So this is qt plus 1 is equals to, that is q learning q value. Q value is right now what Q value that I have. So if I'm in state S, what is my Q value? So in future at t plus 1, what would be my Q value if I take action A in the present state, right? So this is calculated using this whole equation. Okay, RT plus 1 is the future reward, and similarly this is the discount factor maximum of this. And so this is basically overall representing that the overall sum of my the q value of the old state plus the total reward, and the difference of if I move from present to next state, what would be the cost basically. Okay, so this whole system is representing that. So this is Q learning. So in Q learning, only one thing is happening at every state action pair. Whenever I take an action, Q value is updated. Q value is updated, it is learned, and Q value is updated and it is learned. So only this way the model is learning. So model is learning only Q values. It is not learning anything else. It is learning Q values for each and every state. So this is also called exploration. Exploration means that exploration is this one over here, where you have a q value and you explore out of which one is best. Okay, so this is called exploration, and the opposite is just exploitation of the exploration. All right, So exploration, when I'm talking about the q value or q value functions, so this means exploration. Okay. uh, so let's see. So this is example. So instead of looking it at like this, okay, I'll just, okay. So this is TQN network. So what is the requirement of up till now we have not talked about neural network. We have talked about reinforcement learning. Now neural network plays a role. Why does it play the role? So uh, where it is required. Suppose I was in state S1. Now I might have it might have been possible that I have 1,000 possible states where I can go in right now. Okay, so out of these 1,000, which one is best, and I can select any one of them. Suppose I'm selecting this one. Now this one is dependent upon all the future rewards, right? So this is a complex function. This overall is a complex function. So whenever I want to solve, basically what I want is I want to converge this whole set of equations. This might be equation 1, equation 2, equation 3. There can be so many equations, right? It's nothing, just values. So it's equations. So out of these equations I want to converge, and I want to find the best optimal equation which will maximize my reward. Okay, so out of all these equations, what I'll do is I will select this node or this equation where my reward is maximized, and here neural network comes into picture. So whenever I have a complex equation, I use neural network to approximate my function. Okay, so to approximate my function, and input is state and actions, and output is and I want the best q value. Okay, so out of all these q values, so I will select the one which is having the best q value, right? So this is what is happening in a neural network. Out of, I can have so many q values, and out of these I want to go into which state, so that it maximizes the overall my optimal q star. So I'll get final optimal q star, right? So deep q network is nothing, it's just a combination of reinforcement learning plus neural network, where the parameter learned, that is theta, by the model basically leads to convergence. And what convergence? Convergence means we just want to optimize, we just want to reduce or find out the best optimal policy, and which is having maximum reward. Okay, so this is how simple, exact same thing that happens in a neural network. We have some set of inputs, and we have a neural network and a set of outputs. And what do we want to do is we want to converge this function, and we want to learn theta such that loss is less. Okay, so which loss? So this output y loss and predicted loss. Okay, similar thing is happening over here. We want to maximize the reward, and we want to find out the optimal optimal q means where there is a maximum reward. And out of, so we want to maximize it. Out of all these possible q's, which one is the best one, we will select that one. Okay, so it will train, it will update all these parameters theta of the model. Okay, and it will update them, and it will update until we get the maximum q value, right? So this is dqn. Simple uh, thing is there. This Bellman equation we have discussed on the last class also, that we so present state is dependent upon nothing but the present reward plus the discount and the future reward. If I take some action, uh, if the optimal state action value for the next time step, that is t plus 1, or s dash or a dash, you can write it like this, are known, then optimal strategy is to take the action that maximizes the expected value of. So what do we want to do is we want to maximize the expected value of out of all the possible states and actions, right? So same thing. So we have seen this, and so this is, yes, so main point is what will happen is we have multiple states. So I are many, that is infinity. So it's simple in a chessboard also. Suppose in any game you might have multiple states, you might have so many states, like, so it is difficult to converge, it is difficult to solve. So we require some function approximator, and neural network works as the function approximator. Function approximator means wants to solve a complex function. So this neural network is solving this complex function. Okay, so use a function approximator to estimate the action value function. And if function approximator is a deep neural network, it is called deep Q learning. So if instead of neural network it is a deep network, we call it a deep Q learning. Okay. Uh, so that was it. Nothing extra we are doing today. Your unit 4 is completed. Okay. Um, if you have any questions, you can ask. And also, let's keep a revision class, maybe